Hi, hi guys. Today we are going for Spark linear regression. Start Spark linear regression algorithm. Here we are creating Spark session, and here using Spark session we are creating a Spark instance. And let's read the data from e-commerce customer.csv file. So spark session.read.csv, and if you see the parameters, here are the path, schema name, separator, and coding, and these are the parameters. And here we are passing inference schema equal to true, header equal to true. So let's start it. Let's see the schema. If you want to see the schema, just you need to print schema. Just print schema, and it basically contains email address, e-commerce customer data, customer email, customer address, and average session, average length, and time spent on the app, time spent on the website, length of membership, and yearly amount spent. So if you would like to see the data are look like here in the row object. If you want to see in terms, this is the email address, and time spent, app time spent, and yearly amount spent. So let's start. So if you see here, these are the string column, and these are the numerical column. For numerical columns, it will useful for our machine learning. And if we are spending based on these columns, we would like to find yearly amount spent customer, how much yearly amount he want to spend, we want to find using linear regression. So let's start. So first, what we need to do in linear regression, in terms of vector, we need to do vectorization. Vectorization means we need to put all columns together in form of vector. So for that, we have to go from Spark .ml, then you can go here linear edge and import vector assembler, and the linear regression is under regression. So if you click here, you can see various options. Okay, and if you see the columns, these are the column email, all the columns detail. Now we need to do vector assembler. That means we need to put features name. We need only one column called the features. So if you go vector assembler, we are importing here, and if you type a vector assembler, basically vector assembler need input column, output column, and this is the parameter is required. So so let's go so we need input column. These are the numerical column, average session length, time spent, time is one, and website length of membership. And I want to give this all the vector column as a features. The name is output name. So if you see this create a assembler. Now let's transform data. It transport data, and if you want to see data, print the schema. Now if you see the schema, it says extra column called the features. Let's see the data of feature. So this is the raw objects until here it's same, and it's added a new column called the features. And if you see the values features, all 4 columns, 34 is here, then 12, then 39, and length of membership is 4. Yeah, so these are data, but so most of cases this is not required, but we would like interested under 2 columns, this features now and yearly amount. So if you want to select data from data frame, we can just use select and column name features and yearly spent. Now let's see the data is a features, and this is the vector column, and yearly amount is spent. So based on this one, we need to find this one. So let's split the data, training and test. So training data and testing data, and final data. This is the final data, and random split. It will do randomly split, and 30 to 70 to 30%. 70% will be training data, 30% would be testing data. So most of cases people use 80-20. Let's see. Now if you see the training data, we have training data near about 388 rows, and these are mean, standard deviation, maximum, yearly amount. And if you see the testing data, we have 122. So now let's start linear regression, LR, linear regression features. So if you see here, input column default is a feature, but it would be always better to provide a name, and label column output column name is yearly amount we spend. So this is linear regression. Let's fix that. Here we need to put the training data. We fit the data and let's evaluate the model. Now the results, and if you see the result residual, basically this will show actual predicted value and using our model and actual value difference. So if we spend a 500 and difference is 10, that's still valid, and it's like 2%. These are the values. And if you want to see the root 1 square value, so 98 point, that means our model is 98% is correct. No, so root mean square error. So again it's saying root mean square, basically for each value average value is like $9 difference, and root mean square, here we can see the efficiency 98%. That means it's pretty well our model. And the final data, this is we calculated. So final data, we have final data. So if you see the final data, it was here, and we are checking here total 500 rows, mean value is 499, and standard deviation is 79, minimum value is 256, max is 756. So in this case 9.8 is acceptable because he is spending like 500, average is 500. So in the practical example, so this is here we define a model and we will get the unlabeled data, which we don't have the value for amount spent. So what we need to do, we need to find. So basically what we are doing here, testing, I'm taking testing data as a unlabeled data, only feature column I'm selecting. If you see the features, only the features, and we would like to predict based on this one. Then linear model, transform, and we need to pass unlabeled data. And if you see the prediction, it's pretty same. For first record we got 500 and it's almost same. So this is how we need to do prediction. Thank you for watching my video. Hopefully you like it. Please like it and subscribe. Thank you.